Hello everyone. In this lecture, we are going to discuss about the topic code generator in compiler design. Code generator is used to produce the target code for three address statements. It uses registers to store the operands of the three address statements. For example, consider the three address statement x equal to y plus z. It can have the following sequence of codes. That is move y comma r0 and add z comma r0. Here we move the operand y value to the register r0 and add it with the operand z, and the final result will be stored in R0. So we are using these operands y and z to be stored in the registers. We have two types of descriptors in code generation. One is register descriptor and another one is address descriptor. The register descriptor contains the track of what is currently available in each register. The register descriptor shows that all the registers are initially empty. The address descriptor is used to store the location where current value of the name can be found at the runtime. Now let us see the design issues in code generation phase. In code generation phase, various issues can arise. The first issue is input to the code generator. The input to the code generator contains the intermediate representation of the source code and the information of the symbol table. The source program is produced by the front end of the compiler. The intermediate representation has several choices like postfix notation, syntax tree and three address code. We assume that the front end produces the low level intermediate representation. That is, the values of the names in it can directly manipulated by the machine instructions. The code generation phase needs complete error-free intermediate code as an input required. So this has to be considered in the code generation. Next issue is target program. The target program is the output of the code generator. The output can be like absolute machine language, which has the advantage that it can be placed in the fixed memory location and can be immediately executed. Next, we have relocatable machine language. This allows the subprograms and subroutines to be compiled separately. Relocatable object modules can then be linked together and loaded by the linking loader, but there is an additional expense of linking and loading in this output. Next, we have assembly language as the output, which makes the code generation easier. We can generate the symbolic instructions and use the macro facilities of assemblers in generating the code, and we need an additional assembly step after the code generation. So next issue is memory management. During the code generation process, the symbol table entries have to be mapped to actual addresses and levels have to be mapped to instruction address. Mapping the name in the source program to address of the data is done by the front end and code generator. Fourth issue is instruction selection. Selecting the best instructions will improve the efficiency of the program. When you consider the efficiency of the target machine, then the instruction speed and machine idioms are important factors. The quality of the generated code can be determined by its speed and the size. Consider the statements given below as an example: p equal to q plus r and s equal to p plus t. So this is the inefficient assembly code for this statement. So we are moving the value of q to register r0 and add it with r, and the result is stored in r0, and the result is finally stored in p according to the statement number 1. Then in the second statement we need the value of p again. So we move the p value again to register r0 and add it with t, and the result is stored in r0, and finally we move to the s. This is inefficient because the fourth statement is redundant, as the value of the p is loaded again in that statement that has just been stored in the previous statement. This leads to an inefficient code sequence. Next, fifth issue is register allocation. Use of registers makes the computations faster in comparison to that of memory. So efficient utilization of registers is important. So the use of registers is subdivided into two subproblems. During register allocation, we select only those set of variables that will reside in the registers at each point in the program. During subsequent register assignment phase, the specific register is picked to access the variable. To understand the concept, consider the three address code sequence: t equal to a plus b, t equal to t into c, and t equal to t divided by d. The efficient machine code sequence is given here. So we are moving the value of a to register r0 and add it with b, and the result is stored in r0, and then again we multiply the value of r0 to c, because here we move the value t, and t has to be multiplied with c. So instead of moving it, we directly multiply it with r0, and then again we divide the result with d, and finally we move the resultant value to t. So here we are not using any redundant code, so this is an efficient machine code. And sixth issue to be considered is evaluation order. The efficiency of the target code can be affected by the order in which the computations are performed. Some computation orders need fewer registers to hold the results of the intermediate than the others. So thus we have seen the information about code generator and then the design issues in the code generator. Thank you.